Good morning, everybody. Welcome back to lecture number
32.
Last time we talked about how the synchronous generator works. And do you remember what did I tell you? I told you, you have the rotor, you apply a DC voltage. A DC current will flow through the coils. If the DC current flow in a coil, apply the right-hand rule, then I get a magnetic flux. This magnetic flux will be constant. We asked the mechanical engineer to spin the rotor at a speed of 120 times 60 over number of poles. If we spin it at that, what will be the speed of sigma F, or the magnetic flux? It will be the same. So I will have a rotating magnetic field. This rotating magnetic field will induce a three-phase voltage on the stator windings. Remember I told you for DC motor, what is the armature? Rotor. For induction motor, what is the armature? Stator. For synchronous generator, what is the armature? Stator. Keep this in mind. So I have a three-phase voltage, VA, VB, VC. If I have an open circuit, no load connected, will I have an induced voltage?
Yes.
Yes, similar to V Thevenin. If I connect a load, will the current flow?
Yes.
Yes. If I have a generator that is not connected to the load, will I have a current flowing? No. Similar to V Thevenin. I open circuit. What is I open circuit? Zero. So if you look at this slide, for example, I actually adjusted the notation to be VT equal EA. So at no load, there is a terminal voltage, but there is no terminal current. The moment I connect the load, I will have a current flowing with electrical frequency equals to the rotational frequency. يعني إذا rotational frequency 120 times 60 over 4 poles, which is 1800, what will be the electrical frequency at the armature current or the load current? 60 Hertz. If it is 1795, what will be the frequency? Below 60 Hertz, maybe 59.9. So as a matter of fact, if you go to any control room, you will notice that there is a band of allowed frequency of maybe, let's say, 60.5, 59.5, and I have ideally 60. So if I have a curve like that, if I exceed this band, then we have an alarm. So we always have to ensure that the electrical frequency in the stator is within the safe band. And how do we deviate? For example, if you connect a big load, the generator would vibrate. It will resonate. If it resonates, the mechanical movement would not give me the 60 Hertz, maybe give me 61. Do you remember in the summer sometimes light bulbs flicker? إيش معنى flicker? تومة. تولع وتطفي. Why? Because the synchronous generator that is serving the area experienced an out of synchronization moments. I no longer, I have 61, 62 Hertz. ما حتشتغل اللمبات ب 62 Hertz. It will flicker. Okay? Let's continue. Today we will begin here. Let's look at what is happening, what we call an armature reaction voltage. This is the voltage drop that occurs because of the armature reaction itself. What is armature reaction? In the induced voltage. So how do I model that? It is when well known that this is directly proportional to the amount of the stator current flowing. What is the stator current? IA. It is 90 degrees, the voltage is 90 degrees behind. Why 90 degrees? Because I multiply by minus J. If you do by the calculator, what is J? If you type J, shift to 90 degrees. So the RAR, what is AR? Armature reaction. Voltage is minus J times XAR, which is armature reactance. Armature reaction reactance. XAR is armature reaction reactance. Times IA, which is the armature current that is 90 degrees away. So how to model it in a simple electric circuit? I have the induced voltage minus this voltage drop across the stator. This is the first element. I do have a voltage drop on the stator windings. This way the stator terminal will be induced minus some voltage. This is not the story. We have another component. I told you we have an actual voltage drop on the stator winding, but also I have air gap. Do you remember the air gap? The air gap?
Yes.
For synchronous generator, do you think a salient pole will have more leakage? Well, around, think.
Salient.
A salient pole. Why? Because I should have a very big air gap. لأن راس السالينت والستيتر it should have maybe 1 milli, but I have gaps عشان هو salient بيصير the lower part of the teeth maybe has 1 centimeter gap. So salient pole has more leakage reactance. Not all the flux would propagate from a rotor to a stator. So how do I model that? I model that by another inductive element, X aluminum, true or false? No, that's not aluminum. That's armature leakage. X sub armature leakage. So how many inductors do I have? I have an armature reactance and an armature leakage. Do you remember a major one transformer question, leakage reactance?
Yes.
It is the same question, but this one is much bigger. Why it's much bigger? Because the air gap is much larger and it's a rotational device. So flux, it will leak. Not all the rotor flux will travel to the stator. Some of it would be lost in the air because of the salient poles. Not only that, I need to model our favorite resistance, the copper losses. So this is copper resistance, which is Ra. Let's go back to EE201. EE201, do you remember having circuits that they will tell you VS, no, that's EE213. VS, RS, and then they do these blocks, and then they put some circuit. And they usually call this RS. Why we model a voltage source with a series resistance? What is this RS, internal resistance? Do you remember the term internal resistance?
Yes.
So RA is nothing but that internal resistance, which is physically the resistance of the copper wires on the stator. So how many elements do I need to model a synchronous generator? First of all, هل هذه السيركت فيها روتر ولا only stator? It is only stator. So I have internal voltage, I have armature reactance voltage drop, armature leakage voltage drop, internal resistance voltage drop. Then I get my terminal voltage. Is this single phase circuit or three phase circuit?
Single phase.
So is this phase voltage or line to line?
Phase
voltage. Now to simplify the analysis, sometimes they combine XAR or XAL with something we call it X sub S, which is synchronous reactance, which is this circuit. So if you do voltage rise, voltage drop, you should get this equation. Vt is EA minus IA JXS minus IA RA. You do voltage rise, voltage drop. Plus, minus, plus, minus, plus, minus. And do the cable. We're experts.
دكتور التيرن ريزيستنس ليه ما كانت بالسيركت قبل الارمتشر ريزيستنس؟
You can have the RA before the JXS, a serious element, it doesn't matter.
لانه فوق كان يطلع الاي اي ما بينه الاي اي.
No, that's the armature reaction terminal voltage without a leakage with internal resistance. This is E sub T. Before. Sometimes we call internal voltage, we call it excitation voltage. Which is the induced voltage on the stator before losing the armature reaction, before losing the leakage reactance, before losing the internal resistance. Let's talk about the phasor diagram. What is the phasor diagram? It's a representation of the relationship between complex numbers, voltages, and currents. So, what is my reference here? Is it the red, or the purple, or the yellow, or the green, or the blue? The red. It's the terminal voltage, Vt angle 0. I am telling you I have a lagging power factor. So what does that mean? It means Ia lags Vt by a certain angle theta. So if you remember, lagging is minus 36 degrees method. So that's my Ia. Multiply Ia by Ra, it's nothing but a scale up or down. So where the green curve is the blue curve times the scale, we connect the head of the red curve with the tip of the green curve. So I have Vt plus Ra plus JXSIA. I have a J is 90 degrees, so I should have Ia by 90 degrees. So it's the yellow curve plus some scale, which is XS. So I added vector and calculation. Do you remember vector calculation? Physics 101. Do you remember vector calculation? It is the worst course in the university. I really don't like it. It is very scary. Physics 101 is not easy. It's very hard. You agree with me?
Yes.
So, if you add them, you should get the E sub A, which is the excitation voltage or the internal voltage. So what do you notice? You notice in EA magnitude-wise is larger than VT. If I connect a lagging power factor. Let's do a short example. And calculators, please. Calculators. YouTube calculator. We recently have 100 subscribers. I know only 2 or 3 from you. So subscribe to the channel, okay? Yesterday I celebrated the 100 subscribers. Most of them, they don't come from 360, I know. They come from 234.
Yeah, I think because the major is the next Sunday.
Is it the same material? Is it the same material? 360 and 236 and
So 236 is E201 for non-E. So why they call it 236? It's a joke, not real. It's a joke. So it's E236. It was before 234. So 2 from before E201, when I took E201, I didn't take E201, I took E202. And I took E203. And there was a course called E204. That's not real. So they combined 2, 3, 4. And they offered 234. Then the lab of 234 was 235. Then they have 236 because it is 202. I never took E201. It was 202 in my time. 203. And then because of the 204, they call it 6 because they can't have the same course number twice. It's not real, but that's my theory.
And what was the name of E201?
E201 ما كان في E201. So the history of E201, it was E201 in the 90s, then in the 2010s became E202. They were offering E201 للخطة القديمة و E202 للخطة الجديدة. لأن لما راحوا الخطة القديمة رجعوا ل E201.
كوي 200.
I took E200. There was E200, which is COE 202.
Yes, ma'am.
What is 204?
E204 is electric circuit for non-electrical.
For the industrial.
Industrial.
Industrial mechanical.
No more 204 and 204. Everyone was taking E236. No, خلاص. 6 sections. 2, 3, 12 sections they have. So that's not realistic, but that's my guess. But it is true, إنه كان في course 202, كان في course 202, 204. Actually, the best course I took, there was a course 206. It's a 1 credit hour that has modules, small modules. So that this course, maybe one professor comes from power, one professor comes from control, and they tell you what is power. I really don't know why they don't. I also took 311. And in my time, I was not enforced to take any physics.
Math. There's advanced math, I think.
Math 302 is easier than physics 305.
Math 302,
310.
302.
302,
They change.
easier.
They call it advanced math.
Engineering mathematics. It's only for EE students and math students.
I think anything is easier than physics 305.
Physics 305 is not easy. Who's having the major? Three phase, 10 kVA. Why it's not 10 horsepower? No, because this is a generator. How can I market a generator with a horsepower? Do you market a generator by the amount of power needed to operate it, or by the amount of power you get out from it?
You get out.
You get out from it. That's why it's 10 kVA. Is it rated or non-rated? Rated. It is rated for load by design. 208. Is it line to line or phase? Who said phase? Wrong. Because this is a three-phase machine. Do we love phase quantities? Do we market a three-phase? You never market a three-phase power device with not line to line. We love line to line. إيش معناها? We never market any three-phase device with a phase quantity because that doesn't make any sense. So this is a line to line, 4-pole, Y connected. XS is 2, R is 0, RA is 0. The generator is connected to a three-phase 208 infinite bus. What does infinite bus mean? Infinite bus is an infinite bus? An infinite bus is a bus that has a voltage and frequency that are constant even after the variation of the load. Is no, هذا التعريف. It's a bus that has fixed voltage and fixed frequency. So what does that mean? It means load is at 208 at 60 Hertz regardless of whatever happening. A synchronous generator. Then the load is connected to synchronous generator. The terminal voltage is 208 fixed. Now, neglect the rotational losses. The field current. What is the field current? The field current is the current that comes from this rotor. This is IF. The field current and the mechanical input power, are adjusted such that the synchronous generator delivers 6 kilowatt. Is 6 kilowatt rated?
No.
No. Why? Because if you multiply S rated times PF, which is 10 times 0.85, you will get 8.5 kilowatt. That's the rated real power. So we are operating under the rated real power. Clear? Yes. You are allowed not to fully utilize your generator. Find the excitation voltage, which is E sub A, after finding VT and IA. How to solve it? What is VT? 208 over square root of 3. Because VT is the single phase equivalent circuit. You cannot work with line-to-line quantities that easily. Then, what do I have? I have to calculate IA. How to get an IA? How to get an IA? You have to use the formula. What is the formula? P equals square root of 3 V line to line I line cosine theta, which is equal to 3 VT RL cosine theta. What is P? 6 kilowatt. What is VLL? 208. What is PF for cosine theta? 0.85. From that you should get IA to be calculators. 19.6 amps. What is theta I? Is theta V minus theta, which is 0 minus cosine inverse of 0.85. So that's equal to minus 31.8. So that's the angle of the current, that's the magnitude of the current. Then I should calculate EA. I want you to do all calculate EA now. So what is EA? VT. What is VT? It's 208 over square root of 3 angle 0 plus IA. What is IA? 19.6 angle minus 31.8 times RA is 0 plus J times 2. If you do the calculation, you should get 144.5 angle 13. Is it clear? So in a lagging power factor, this problem can be drawn using this. So I might ask you in the test to draw, and I will ask you in the test, draw the phasor diagram. and it doesn't have to be scaled, but it should be generally the same shape, like this, for a lagging arc. Do you remember this curve? For an induction motor, what was my input? Electrical. What was my output? Mechanical. Here I flip it. Here my input is mechanical torque times speed, omega m, which is very close to omega sync. Very small difference. You cannot have exactly mechanical speed, but if it's 1800, maybe it's 1798 RPM. You can say roughly is omega sync. What are the losses? I was experiencing stray losses with friction اللي كانت على اليمين صارت على اليسار. I should have the core losses. The core losses mainly هي air gap losses. Then I should have developed air gap torque, air gap power. Then I have only I square R losses, copper losses في الستيتر ولا في الروتر؟ في الستيتر. So this is a stator. This is rotor. Why I ignore rotor copper losses? Because it's a small DC. Why I include 25 volt في generator that has 10 kilovolt? So that's why we only consider RA for the equivalent circuit. Do we consider R rotor? But for the induction motor, we had to include both the stator and rotor. You remember that?
Yes.
We have XS, RS, RR, slip. Then the output power is square root of 3 VLIL cosine theta. Next lecture we will continue with power angle characteristics. Okay? Any question? Come on.